A coding model with 30 billion parameters and only 3 billion active changes the question, not because North Minicode is suddenly the smartest coding model in the room. That is the wrong fight. The real fight is whether your expensive model should still be doing the boring turns, because most agent work is boring turns. Find the file, read the function, list the tests, summarize the error, patch one line, run the check, read the failure, patch the next line. None of that needs a genius every single time, but most developers still run it through the biggest model they can afford, because the model picker makes that feel safe. That is why North Minicode is interesting. Cohere is not just saying here's another code model. It is saying here is an agentic coding model with 30 billion total parameters, 3 billion active parameters, a 256K context window, a 64K output limit, Apache 2.0 licensing, and a design aimed at local or controlled deployment. That combination points at a very specific future. A future where the premium model stops being the whole coding agent. It becomes the planner, the reviewer, the hard decision maker. And a smaller active model becomes the worker that burns the tool turns. That is a much more dangerous idea than just another benchmark score. Because if it works, the pricing model of AI coding starts to look silly. You should not pay frontier model prices for every grep, every summary, every tiny edit, every retry, and every failed test explanation. You should pay frontier prices when the mistake is expensive. North Minicode is interesting because it asks how much of the coding loop can move below that line. Not can it replace Claude for everything. Can it replace Claude for the parts Claude should never have been doing in the first place? Hey, don't forget to like and subscribe for more like this. Now back to the video.
The number that matters is not 30 billion. It is 3 billion active. Mixture of experts models make parameter count slippery.
A model can have a large total size, but only route through part of itself for each token. So when people say 30 billion, it sounds like a mid-sized serious model. When you hear 3 billion active, the story changes. Now the question becomes throughput, memory, latency, cost per turn. How many tool calls can you afford before the agent gets expensive? That is the actual coding agent metric. A chatbot can be judged per answer. A coding agent has to be judged per loop. If the agent needs 30 turns to solve a bug, every turn matters. If 10 of those turns are just reading files and summarizing results, using the most expensive model for all 10 is waste. That waste used to be hidden because the interface felt simple. Pick the good model and let it work. But once agents start running longer, the bill exposes the lie. The expensive model is not just doing hard reasoning, it is doing paperwork. North Minicode is a bet that paperwork can move to a smaller active model that does not make it a toy. It makes it a worker. And workers need a different evaluation. You do not ask whether the worker can design the architecture of the whole app from a blank prompt. You ask whether it can reliably execute a bounded task. Can it find the right symbol? Can it edit without destroying nearby code? Can it read terminal output correctly? Can it retry without spiraling? Can it stop when the check passes? Can it hand the hard decision back to a stronger model instead of bluffing? That last one matters most. A small active model does not have to be brilliant to be useful. It has to know its lane. The best way to think about this is not local model versus cloud model. It is factory floor versus architect desk. The architect should not personally carry every brick. The brick carrier should not decide where the building goes. Right now, many AI coding setups use one model for both jobs. The same model searches the repo, reads package files, writes the implementation, interprets tests, writes commit messages, and reviews the final diff. That is convenient. It is also blunt. A better setup splits the loop. The premium model gets the first real thinking turn. What is the likely cause? What files should matter? What is the smallest safe change? What risks should be checked? Then North Minicode takes the execution work. Open these files, extract the relevant functions, make the mechanical change, run the targeted test, report the failure exactly. Try the next patch inside the same boundary. If the failure escapes the boundary, stop and escalate. That is the workflow that makes a 3 billion active coding model interesting, not heroic autonomy. Disciplined delegation. The surprising part is that disciplined delegation may beat raw intelligence for many everyday tasks. Most coding work is not inventing a new architecture. It is changing the validation rule, adding the missing test, renaming the field, fixing the import, adjusting the API payload, updating the query, replacing a deprecated call. Those jobs still need care, but they do not always need the most expensive brain in the system. They need a model that can follow instructions, use tools, and keep the patch small. If North Minicode can do that, it has a job, a very large job. The Apache 2.0 part is not decoration. For developer tools, licensing changes adoption. A model that can be used commercially, modified, deployed privately, and wrapped into internal tooling without a legal puzzle has a different path into teams. That matters because the best use case for a worker model may not be a consumer chat app. It may be inside a company agent stack, a Team can run the planner through a managed provider, but keep repetitive repo inspection and code editing closer to its own environment. A company might not want every search, every file summary, every failed test output, and every tiny private module going to the most expensive remote model. Even if the provider is trusted, cost and policy still matter. A local or controlled worker gives teams another lever. Send the high judgment turns out. Keep the mechanical turns in. That does not solve privacy by magic. Local models still need logs, permissions, sandboxing, and review. But it changes the default shape. Instead of asking one cloud model to see everything, the agent can route work based on risk, low-risk local search, low-risk summary, low-risk fixture generation, low-risk first pass edit, high-risk architecture, high-risk security review, high-risk migration plan, high-risk final approval, that is a sane split, and North Minicode sits exactly where that split starts to become practical. Not because it is tiny in every sense. The hardware story still matters, but because active parameters are a signal that the economics are moving, the worker model does not need to win the whole race. It needs to be cheap enough and reliable enough that the premium model looks wasteful on routine turns. The test I would run is simple. One repository, one failing test, one known bug, 3 setups. Setup 1 uses a frontier model for the entire agent loop. Setup 2 uses North Minicode for the entire loop. Setup 3 uses a frontier model for planning and review, then North Minicode for search, edit, and retry. The third setup is the one I care about. If North Minicode fails as the only brain, that is not shocking. If the frontier model wins when allowed to do everything, that is not shocking either. The real question is whether the hybrid setup gets close to the frontier result at a much lower cost. And the scoring has to be practical, accepted diff. Number of tool calls, number of wrong files opened, number of times the model repeated the same failed idea, amount of human intervention, final patch size, whether the agent named the remaining risk. That is better than asking whether the answer sounded good. A worker model can write mediocre prose and still be useful. It can be boring and still save money. It can fail on big design questions and still win on the loop it was assigned. But it cannot be sloppy with tools. Tool sloppiness kills the whole idea. If it misreads command output, it is not cheap. If it patches the wrong file, it is not cheap. If it hallucinates a test pass, it is not cheap. If it loops until a human stops it, it is not cheap. Cheap tokens only matter when the turns are useful. That is the standard, not cheap model, cheap useful turn. There is a trap here that will catch a lot of people. They will hear local coding model and immediately ask if it can replace their current agent. That is the wrong adoption path. Replacing the whole agent is the hardest version of the job. It forces the model to plan, search, edit, debug, review, and decide when it is done. A 3 billion active model does not have to carry all of that on day one. The better path is to make it responsible for tasks where failure is visible. Summarize this file, find every call site, draft the mechanical part of this change, write the obvious test cases, extract the error from this log. Check whether this patch touched files outside the plan. Those are useful jobs because the result can be verified quickly. The premium model or the human can inspect the output. The test can catch many mistakes. The diff can be constrained. The blast radius stays small. That is how small models should enter coding workflows, not as fake senior engineers, as constrained workers that make the senior models spend less time on noise. This also changes the user interface. A good North Minicode workflow should not just give you a model selector, it should give you routing. This task is safe for the worker. This task needs escalation. This tool is allowed. This file path is reserved. This diff is too large. This failure repeated twice, so stop. That is what turns a small active model into infrastructure. The harness has to protect the model from jobs it should not own. The local part is also more complicated than the title version. Local does not automatically mean free. Local does not automatically mean fast. Local does not automatically mean private in the way people casually imply. If the model runs on your machine, but the agent logs everything to a remote service, that is not private enough for sensitive work. If the model needs hardware you do not have, local becomes another shopping list. If it is slow enough that the agent loop feels sticky, you will stop using it. If it needs constant setup, it loses to the cloud button. So the North Minicode story has to be honest. The promise is not that every developer can instantly replace paid coding agents with a laptop and a dream. The promise is that the active parameter count and open license make a worker model strategy more believable. That matters most for teams that can run infrastructure. It also matters for local enthusiasts who are willing to trade setup time for control, but the win is not emotional. It has to show up in the loop. Lower cost per useful turn, acceptable latency, good enough patch accuracy, clear escalation when the task is hard, small diffs, no fake confidence. If those are not there, the model is just a cool download. If they are there, the model becomes part of a stack, and that stack is the real story. This is where the market is going. Not one model to rule the repo, a routed agent stack, a planner model, a worker model, a reviewer model, a repo index, a test runner. A permission layer, a memory layer, a human approval point. North Minicode is one possible worker in that stack. Maybe it becomes a default. Maybe another small active coding model beats it. Maybe the exact name changes in 3 months. The pattern will not disappear. Expensive models are too valuable to waste on low judgment turns. Small models are becoming too capable to ignore. And coding agents are made of so many repeated tool loops that the economics will force routing whether the UI exposes it or not. That is why I would not judge North Minicode by asking it to build an entire SaaS app while unsupervised. That test is entertaining, but it is not the most useful. The better test is uglier. Can it save 50% of the premium turns in a normal bug fix workflow without making the human supervise harder? Can it do the boring parts cheaply enough that the strong model feels sharper when it appears? Can it make local execution feel like a worker, not a punishment? That is the bar. If it clears that bar, it does not need to replace Claude. It only needs to make using Claude for everything look lazy. The ending here is not that North Minicode wins. The ending is that the model picker is becoming too simple for coding agents. Pick one model and let it do everything was fine when the agent was basically chat with tools. It is not fine when the agent becomes a development system. You would not run every process in production on the most expensive machine just because it is the strongest one. You route workloads. You cache, you isolate risky operations, you measure failure. AI coding is moving toward the same discipline. North Minicode matters because it gives that discipline a concrete shape. A small active coding worker, long context, open license, agent training, local or controlled deployment. That is not enough by itself, but it is enough to ask a better question. Which parts of my coding agent are intelligence work and which parts are execution work? Once you ask that, the old workflow looks wasteful very quickly. The expensive model should not be reading every boring file. It should not be writing every obvious fixture. It should not be spending premium tokens discovering what a cheaper worker can discover. It should arrive when judgment matters. That is the future North Minicode points toward. Not a tiny model pretending to be a senior engineer. A small active worker that makes the whole agent stack cheaper, calmer, and easier to scale. That is a much more believable revolution, and honestly, a more useful one. Here's the everyday version of the North Minicode workflow. You open an issue that says the export button is broken. The premium model should not immediately start editing. It should first decide the boundary. This looks like a front-end event handler, an API route, and maybe a permissions check. The worker model can now do the grind. Find the export button. Find the route it calls, find the tests around exports, summarize the payload shape, list the last 3 related changes from Git history. None of those steps is the hard decision. They are evidence gathering. If the worker opens the wrong file, the cost is low. If the worker summary is incomplete, the premium model or a search can correct it. But if the premium model does all of that every time, the setup is paying senior rates for filing work, then the premium model comes back for the decision. The bug is probably in this mismatch between the client field and the server validator. The smallest safe change is here. The risk is that old exports may depend on the previous name. Now the worker can return for the mechanical patch, change the field mapping, add one test, run the export test, report the output. If the failure is simple, continue. If the failure points at a deeper contract problem, stop. That stop condition is what makes the workflow professional. Small models become dangerous when they are asked to keep pushing through uncertainty. They become useful when they are allowed to say, this is no longer my turn. That is why I keep calling it a worker model. A worker is not a lesser tool, a worker is a scope tool. The scope is the value. There's also a review story here. A small active model does not only have to write code, it can check whether the agent stayed inside the plan. That sounds boring, but it could be one of the best uses after a patch. Ask North Minicode to compare the diff against the original task. Did the agent touch files outside the stated boundary? Did it add a dependency? Did it change generated files? Did it alter tests without changing implementation? Did it remove a check instead of fixing the failure? Did it create a bigger diff than the plan justified? These are not deep architecture questions. They are disciplined review questions, and they are exactly the kind of thing a cheap model can do repeatedly. Imagine every agent run ending with a low-cost worker audit before the premium review. The worker does not approve the change. It produces a checklist of risk signals. Then the stronger model or the human decides that could save attention. It could also catch the classic agent mistake where the model technically fixes the test by weakening the behavior. This is where North Minicode becomes more than a local novelty. It becomes a way to add more checks without multiplying the bill. The future coding stack may have several cheap worker passes, one for search, one for edit, one for review hygiene, one for test output explanation, one for documentation update drafts. The premium model only appears when the question actually needs judgment. That is the cost structure that makes sense. The old model picker hides that structure. North Minicode exposes it. So the question I would ask before using it is not, can this replace my favorite coding agent? The question is, What is the first expensive habit it can remove? Maybe it removes premium file search. Maybe it removes premium test explanation. Maybe it removes premium mechanical edits. Maybe it removes premium first draft code review. Pick one, measure it. Do not move the whole workflow at once. A small worker model should earn trust by taking one boring job and doing it reliably. If it saves money but makes you check everything twice, it failed. If it saves tokens but adds latency that breaks flow, it failed. If it writes more code than asked, it failed. If it cannot report uncertainty, it failed. But if it takes a boring, repeated part of the loop and makes it cheap, visible, and reliable, that is enough. That is the quiet revolution. Not the headline where a tiny model builds an app alone, the practical shift where premium models become rarer inside the loop. A stronger model still matters. Maybe it matters more. Because once the cheap worker removes the noise, the strong model can spend its attention on the decision. That is how real teams work. Junior developers do not replace senior developers by doing every job. They make the team faster when the work is scoped, reviewed, and matched to skill. North Minicode is the model version of that idea. It is not glamorous, it is useful. And useful is what AI coding needs more than another dramatic model war.